Good afternoon, ladies and gentlemen. Good morning for those who it's morning, and good evening for those who it's evening. Thank you for getting time to be here with us this day as we try to have a discussion around artificial intelligence and what it means in our daily life, especially in academia and in research. This webinar is hosted by Consortium for Advanced Research Training in Africa, that's CARTA, which is basically a flagship program for African Population and Health Research Center, APHRC, with directorship from both APHRC and University of Witwatersrand in South Africa. The aim of CARTA is basically to support development of a vibrant African academy that leads world-class multidisciplinary research with positive impact on public and population health. And we have been in existence for about over 20 years. It started in 2008. So we're looking at about 26 years. We have had cohorts, 10 of them this far, and we are in the process of having the 11th cohort of graduates, PhD graduates that we work with. In our midst of this working, we are exploring new ways of making sure that we remain very relevant and on top of things. So today we want to make an exploration of artificial intelligence. What is it? What attitudes do we hold? What are fears that within academia and research? What power does AI hold in terms of research themes? Literature review, data analysis, teaching, and that kind of scenario. And does AI have any relevance in administrative tasks at the universities or research institutions? How does that come in terms of research and research management? We would also want to just make a discussion around what opportunities are there for us to be able to tap into to remain relevant strategically. And this is the first of a two-phased webinar. We're going to hold another one on the 17th of this month. And if need be, based on our discussions, then we're going to have another one within the year. So for today, we have Professor Benjamin Rossman, who is going to be our main presenter. Professor Rossman is a professor in the School of Computer Studies, Science, and Applied Mathematics at the University of Witwatersrand, South Africa, where he runs robotics and autonomous intelligence and learning laboratory, and is the director of the National E-Science Postgraduate Teaching and Training Platform. He is also the Chief Science Officer for Lelapa AI. Professor received his PhD in informatics from the University of Edinburgh in UK in 2014. He is the founder of the Deep Learning Indaba Machine Learning Summer School, which now are satellite events in 47 African countries. He was made 2024 National Geographic Explorer, a 2022 CIFAL Azrael Global Scholar by the Canadian Institute of Advanced Research, and was a 2017 recipient of Google Faculty Research Award in Machine Learning, and a 2021 recipient of a Google Africa Research Award. In 2020, he was made a senior member of IEEE. The professor is going to be with us for today, giving us the inaugural presentation on AI. Because of the numbers that we have, please, if you have any question that you want to post, please put them on the chat. We are going to follow. We might not answer all of them, but we can do a random check during the Q&A session and have those responses going on. After that, we're going to have Susan, who is going to be making a response to what Prof is going to talk about. I'm going to introduce to you Susan later. Welcome, Prof.
Thanks so much. It's great to be here. Can you hear me all right?
Yes, we can. Thank you.
All right. So let me just share my screen quickly while I've still got you here, and you can tell me, you can check that you can see everything. All right. Is that visible? Can you see my slides?
It's coming. There it is. Very, very.
Okay, great. All right, so it's an absolute pleasure to be here. Thank you so much for having me. And, you know, to talk about something that's very near and dear to my heart, which is AI, that's kind of suddenly exploded and is really affecting everybody in all sorts of different ways. And it's just wonderful to be able to be here to share my thoughts with you. What I want to do today is talk a little bit about how the modern wave of AI works. And I think this is important because, you know, there's a lot of misconceptions around how it works, and it's important to have some sort of insight into what we mean when we talk about AI, particularly when we think about the applications and how to use it in different contexts. Following that, I'm going to touch on a few different ideas of how kind of the modern wave of AI is useful in academia, some of the things I've been doing. This is by no means exhaustive, but hopefully this will point a few lights in different directions. And I'm sure everyone here has been using it in different kinds of ways, and I would be very keen to hear about that in the discussion. All right, so let's take it away. I think a good point to start is asking what is artificial intelligence. Now, it's got a long history. It means different things to different people. Up until a few years ago, when I would give talks about this, you know, the first thing that would jump to mind is people pointing out sci-fi movies like The Terminator or Star Wars. But really, as of kind of the end of 2022, in fact, the 30th of November 2022, when ChatGPT was launched and made public, or at least ChatGPT version 3, the one that became so popular, that's really what people find synonymous with AI. So everyone kind of we joke in the field that you know, it's been about 1.5 years since our field was invented. The real history of the field goes back to the 50s. I'm going to touch on that briefly, but you know, I think for a lot of what I'm talking about today, I'm going to talk about ChatGPT as a bit of a something quite iconic that people are familiar with, even though that represents just one model among many in just one kind of branch of the big family tree that is artificial intelligence. So really, it's a much bigger, much broader field, but that's, I think, what most people are familiar with. So what people think about when we talk about AI is what we nowadays call good old-fashioned AI. And this is the idea that you can describe some sort of state of the world, some configuration of the world, with a set of statements that can be true or false. And from these statements, you can draw inferences. So you might, for example, say that Andrew is the son of Mary, and Bob is the son of Mary, and these are facts about the world. And then maybe from that, you could draw some inferences. You could say, and therefore, maybe we can conclude that Andrew and Bob are siblings. Now, as I say, this is how a lot of the field has worked for many, many years, and really was one of the flagship ways of thinking about it. And we can solve really interesting problems by doing this. So if you look at this scenario I've put over here, we could have 3 blocks. We could say there's nothing on C, C is on A, and A is on the ground. And there's nothing on B, and B is on the ground, and A is next to B. And those statements describe everything I might care about the world. Now what I could do is I could maybe say there's a robot next to it, and I might have a problem I want to solve. I want to end up in a situation where there's nothing on A, A is on B, B is on C, and C is on the ground. Again, I can describe this with a set of formal statements. And for the longest time, AI was interested in solving these kinds of problems that are based around what we call formal logics or propositional logics, the kind of logics you get taught in philosophy or in mathematics. And there's really efficient ways of thinking about these kinds of problems. In fact, these kinds of techniques have been used to solve problems like loading and unloading shipping containers in ports around the world. They've even been used to kind of control spacecraft. And what's really nice about this is you can think of a database of facts about the world that are either true or false. And we can look at that database and we can say, oh, it doesn't know this, or oh, it does know this. We can change what it knows. We can insert kind of assertions. We can force it to do certain things. It's a really nice, logical, structured way of thinking about the world. Now, this is called good old-fashioned AI today because that's not really the modern way of thinking about AI, although people do this kind of work still. The challenge is, this worked great if I had some blocks that I wanted to control. But what if I want to do something like tell if something is a cat or a dog from an image? Now, this is something that I don't know how to specify in formal statements like this. How would you solve this problem? How would you describe to a computer how to tell the difference between these two scenarios? In fact, we could even take another example. How do I tell if something is a face or not a face? Well, maybe I could describe this as a set of these kind of statements that say, well, this is easy. There's two eyes over a nose over a mouth. That's what defines a face. But then the problem is, if I turn my head 90 degrees to the side, I've now broken the system. Or if I'm a one-eyed pirate, I've now broken the system. Let alone that I haven't specified how do I tell if something's an eye or a nose or a mouth. And the challenge is that these kinds of problems are really hard to solve. But there's an insight here that although it's hard to solve this problem, it's really easy to collect the data. It's easy to go out into the world and find loads of pictures of faces, or things that aren't faces, or things that are dogs or cats. And so if I can collect all of these examples, maybe I can get the machine to figure out the rules for me instead of specifying them myself. And this is what we call machine learning. Machine learning is kind of the modern powerhouse behind the way we think about AI these days. So let me give you a very, very toy example of how this works. Let's say we want to classify if something is a dog or a cat, but instead of images, let's do something simple. We're just going to look at the size of the animal and how domesticated it is. So I could think of putting examples on a set of axes here. The x-axis is how domesticated it is, the y-axis is the size, and here are two examples, right? Because the idea is that I'm not going to figure out what the rule is to tell the difference. I'm going to find examples. So if I go out into the world and collect one example of a dog, one example of a cat, and draw them on these axes, I could then ask the machine, figure out where to put a line to tell the difference between them. Now, there's infinitely many lines you could fit to separate these. And so what I want to do is be collecting more and more examples. And as I get more examples, my machine finds a better place to put this line. So this is what we call learning or training. So the system is learning based on these examples exactly where this line should go. And why do we want that? Not to answer the question for these 6 examples, because I already knew the answer for that. But if I give it a new example, I want it to be able to predict something. This is a cat or this is a dog. And so again, this is the idea that the solutions are based on the data rather than us spending a lot of time kind of engineering exactly how the rules work. Okay, but how do we do this at a bigger scale? This is the very simplest example I can show you. Like, how do we build a bigger system that can make these kinds of predictions? Something we can draw inspiration from, and that's the brain. The complex thing we know of in the universe is something that's pretty for that matter. Now, how does this work? Well, the key element of the brain is the neuron or the brain cell, and you've got something on the order of 100 billion or so of those. But what's interesting and important here are the connections between the neurons, right? And these are the synapses. Okay, you've got something like a quadrillion of these. Now, how this machinery all works together is that a neuron does something called firing. It sends a signal to other neurons. So these are electrochemical signals, and when one neuron sends a signal, this travels down the synapses to whichever other neurons it's connected to, who receive that information, and if they receive enough information, they send on their own signal. And so you get these kind of cascading waves of activity across the brain. Now, somehow in all that magic, we can do everything that we know and love as humans. And what is the magic there? It's really in the synapses. We can think of everything we do as humans kind of changes our brains somehow. The fact that you can remember what you had for breakfast or how you got to work is because you've learned something. What does learning mean? Well, it turns out it means something about the connectivity, this kind of structure in the brain is changing with every experience you have. Now, how do we think about this? Well, we can take quite a simplistic version of this and say, all right, let's say we've got these 6, what we're calling input neurons on the left. Now, they send these signals along these synapses. And if the output neuron receives enough signal, as I say, it sends on its own signal, which is what we call firing. Now, these connections, these synapses have different strengths. They can be stronger or weaker, and they can be kind of positive or negative, which we call excitatory or inhibitory. If they're inhibitory, they actually make it less likely that the output neuron sends a signal. And every time anything happens, these kind of connections between these neurons are changing. And this is kind of the basic piece of the puzzle that we use in computer science and in AI to get our systems to learn. So we take a bit of an abstraction to this idea that looks something like this. All right, we get rid of the kind of neurochemical type structures. We say, all right, what if we have a simple system that looks like this? On the left, we're going to have properties of the animal we want to classify. So this might be, what is the size or the level of domestication of our animal, but maybe it's also the noise it makes or the smell or the color or whatever information we happen to have. And on the right, we want to make a prediction. Is this a cat or a dog? Now, how's this going to work? We're going to kind of say each of these properties has an importance associated with it, which kind of maps to these synapses I was talking about a second ago. So what we kind of want to do is to say, well, to figure out if something's a cat or a dog, you've got to look at all these properties and decide which of them are most important and how important are each of them. But the point is we don't want to have to figure that out ourselves. We want this to be learned. This is I'm smaller, and I sum this all together, and somehow that's going to give me my prediction. And what I want to do is figure out how do I change these importances so that it actually learns what I want it to learn. Well, let's look at how this works. Let's say I take my first example and I encode in those properties over there. What I do is I ask it to make a prediction. So it takes all the values in those properties, multiplies them by the importances, adds them together, and basically spits out an answer for me. So it might say, I think this is a dog. In which case we say, okay, that's a great learning algorithm. It's a great neural network. Well done. We don't need to do anything. That was the correct answer. Okay, so it correctly made a prediction. We're happy with this. So let's try another example. Let's say I took this other animal, this cat, and I encoded in these properties. And now I ask it to make a prediction. And it does the bit of calculations. And it thinks this is a dog. So then I say, no, that's a bad algorithm. Actually, this was a cat. Because here, this was a training example. I know the correct answer. So I can say this was a cat. And what I do is I make it change these connections. I change these synapses to make it less likely to make that error again. Okay, so this is just a little bit of calculus, a little bit of matrix algebra. It just makes it less likely to make that mistake. And now I show it these examples over and over and over and over again, and different examples. And eventually these weights kind of learn to be the best values. It's kind of learning how to tell the difference between these two things. Okay, now I've shown you this for these two examples, this cat and the dog, and in the previous example I showed 6. To train the original ChatGPT 3.5, we needed 570 gigabytes of text, which is a huge amount of text, right? That's like all the text online, that's Wikipedia and coding repositories and you name it, all sorts of things went into this. It was huge amounts of text there to learn from. Now, let's look at exactly what this means to do this in text. But before we do that, just one note on the complexity. So this is the kind of model I've been showing you. But in reality, we need more complexity. So here we've got 5 input nodes, 1 output node, and a connection from each on the left to the one on the right. In reality, we add more complexity. So here I've added 7 hidden nodes in the middle. I've connected all the input nodes to the hidden nodes to the output node. And what this means is the number of connections grew from 5 to 42 in this case. Now, this is important because I need more of these connections to be able to model more complicated structures. If I'm just fitting a straight line, I don't need that much. If I want something really complicated like I see in ChatGPT, I need a lot of structure to this. Now, these connections are what we call the parameters of the model, right? These are the important things. And as we've said, these are the things that need to be learned. And what's interesting about this is they form a kind of distributed memory. So everything that this model knows about telling the difference between cats and dogs is encoded in this case in 42 different numbers. Now, this is very different to what I was saying before, right? When we looked at the good old-fashioned AI, everything our system knew was in a database of facts that were true or false. We could look at them, we could evaluate them. Here, the knowledge of the system is 42 numbers. I have no idea what this knows, right? I only know what it knows in the context of giving it examples. And this is one of the key limitations of these models. And this is kind of what raises a lot of the problems. This would be the same as me saying there's a quadrillion connections in your brain. I could think of each one of these as a number. And if I write out a quadrillion numbers, then that's the blueprint of your brain, right? But there's no way I can just look at those numbers and know, this is what your values are on this issue or that issue, or this is your favorite food. Like, it's really hard to distill information out of this. And this is the challenge. The way that knowledge is represented in these systems is really complicated. And in fact, we go to something like ChatGPT. The original version had 175 billion of these, right? So you look at 175 billion numbers, that tells you what it knows, what it can do, can't do, what all the safety limitations are. The current models can be 10 times bigger. In fact, people are building bigger ones, but this is really difficult to pass. Okay, so let's just turn our attention back to text for a second. I was showing you how to predict a cat or a dog. How does this translate to something like ChatGPT? Well, in this case, what I'm trying to predict is, given some text, can I predict the next word? That's the prediction problem here, and that's kind of what ChatGPT is doing. So to do this, I need to give it a lot of data. The data I'm going to give it is Tolstoy's War and Peace, because it's a particularly big book. What we're going to make it do is read this book over and over and over again. That's its training, and get it to predict the next thing, the next word. Okay, although let's make it harder. And instead of predicting the next word, what we're going to do is let it predict characters. So it doesn't even know words exist. It's going to predict uppercase letters, lowercase letters, or punctuation. And again, what we're going to do, it reads the book a number of times, and then I ask it, generate some text. What have you learned? And if I get it to read the book 100 times, this is what it can generate. Absolute garbage. This is completely useless. It knows nothing. Okay, but maybe we just didn't give it enough data. So I'm going to let it carry on going. Now, let's say we get it to read the book 500 times and generate text. Then it gets something like this. Now, this is interesting because this looks like English, right? We expect English because the book's written in English. What we can see here is that these all kind of either real English words or look close to real English words. The punctuation kind of makes sense. There's no full stops in the middle of words. There's only capital letters after a full stop or something that looks like it might be a name. There's some structure here that makes sense. And we can keep going. If we read the book 2,000 times and generate text, you can see very complicated structures emerging. We've got things like an open quotation mark, and then a few words, why do what that day, with a comma, close quotation marks, replied Natasha. This is a really complicated grammatical structure that's been learned by just reading this book 2,000 times and just training to predict the next letter. Now, this is amazing. This is really cool. And this was the state of the art up until about 2015, 2016. But there was a problem, and that's that this kind of system forgets the older context. So what it's doing is it's looking at the last some number of letters to predict the next letter. But by doing that, you can't really follow a narrative, right? If it's talking about here Natasha and Princess Mary, within 2 paragraphs, it's probably going to forget they exist because it's only looking at the last few, maybe a couple hundred characters. So how do we solve this problem? Well, this was a big kind of problem holding back the field for a very long time. Until 2017, when there was an interesting breakthrough called a transformer. And this paper came out, it was a very big deal, and this is the powerhouse behind ChatGPT and all of the modern AI we see today. So this was a big breakthrough. And the idea here was that a transformer doesn't just look at the last however many previous characters, it learns which characters to pay attention to as it's trying to predict something. And this is the idea here is about kind of understanding the context of a word. So, if we look at these 2 sentences, the tree's bark is rough and the dog's bark is loud. The word bark is the same in both these cases. When we see it written on the page, how do we know what it means? Well, we look at the context, right? We've kind of learnt over time that certain words in the sentence are relevant things to pay attention to if we want to be able to make sense of the sentence. And this is what this transformer does, right? So here's a picture of it. I'm not going to go into the details now for time reasons. It's a very cool model, but the idea here is, again, instead of just looking at the past few characters, it's trying to figure out what in the text that I've seen so far is important. This is the huge power of it. Okay, so this is kind of in a nutshell, how this works. The T in ChatGPT stands for transformer. So that's what's going on here. But let's look at exactly kind of how this is useful. Well, if I can try and make sense of text to predict another word or something, I can also make sense of text to predict something else, to maybe generate images. And this is something that's also become quite popular now, is taking text and generating images from that. So I'm showing you some examples from DALL-E, which is from the same company that makes ChatGPT. And you can see examples like this. I can give text that says a raccoon playing tennis at Wimbledon in the 1990s. And sure enough, it'll generate an image for me. Now, what's interesting to note here, when you look at this image, it functions as an image. It's not kind of little pieces of other images stitched together. This is a coherent image that makes sense by itself. And in the same way, the content that gets generated by these models is kind of new content that's being kind of not crudely pieced together, but it's actually being generated by this, in quotes, artificial brain. Much in the same way our own brains generate new thoughts for us, generate memories when we think of things. It's generating stuff in this way. Let's look at a few more examples for fun. We could look at an Italian town made of pasta, tomatoes, basil, and parmesan. Maybe we want to look at a photo of a hip-hop cow in a denim jacket recording a hit single in the studio. Or just because some things never change, a medieval painting of the Wi-Fi not working. And what you can see here is that it's understood everything from the content to the style, ranging from a painting to a photo from the 90s to a modern photo, right? There's a lot that's conveyed here in this text, and this is what this kind of neural network is good at extracting. Now, this is the first thing that I think is valuable for us as academics. If you want to give a talk, you've got to have ridiculous images in it. It's great to have a tool that gives those to me instead of me spending hours doing obscure Google image searches. All right, but let's go forward a bit. What can ChatGPT actually do? And again, ChatGPT is representative of a whole family of these techniques. Now, these are what we call large language models. As a computer scientist, we're very bad at very good at naming things. It's large because it's got lots of parameters, and it's a language model because that's what we call these things that work with language. Right, but the key is in the language. That's what it's good at. It's good at languagey things. What are languagey things? Writing emails and letters and changing the style of text, translating text, writing creative things like poems and songs and short stories, and then some other stuff. So at its core, it can write and debug code. It can solve maths problems. It can develop lesson plans, but it's not doing this in any other domain other than language. Okay, so it might be able to give you a lesson plan because it's seen lots of lesson plans in the data it's been trained on. So it doesn't understand in the sense what it means to give a lesson, but if it's seen loads of examples of lesson plans online or loads of examples of kind of addition problems, it's got some handle on that from its training. So at its core, language is what it's good at. Now, there's some caveats around this we'll talk about in a couple minutes, but this is the big deal. So what can we do? We can give it random things like write a rap about purple ducks robbing a bank. And sure enough, it understands what we want. It understands the content. It understands the style. I can even give it images to go with it. Okay, maybe this is for relating to some students. More importantly, what we can do is say something like, write a bubble sort algorithm to sort a list of numbers in Python. Now, this might be the kind of question I could ask a first-year computer science student implementing algorithms. And sure enough, it does that. Not only does it do that, but it explains to me what it's doing. Okay, now this turns out to be correct. Now, this was like a very early version of ChatGPT that couldn't code, but it could generate the code because it knows what kind of text I'm expecting to see. In subsequent versions, they now plug into code compilers, and I'll show you that in a minute or two. But this one couldn't. It just knew what text I would be expecting to see. I can then even say to it, run the code, and it gives me the output. So I just want to quickly flag, without going into it in too much detail, it's lying to me. This version couldn't run the code. It just generated the text it thought I wanted to see. And that was the text that was most probable to be generated. Okay, but maybe kind of getting into what are these limitations, there's quite a few. But these change all the time. Every tool is different. Every new version is different. These get retrained every few weeks. So, but I think the general principles are here. Firstly, famously, these things aren't guaranteed to be factual. Much like our own memories, they hallucinate. They make up things, right? And I think this is important. This means we've got to pay attention to what gets generated by these models. But I do think this point is in many cases overblown. It doesn't mean you can't use it. It just means you've got to pay attention. It can show biases. This is well understood. A lot of the data on the internet isn't incredibly balanced between all races and genders and people of different political leanings. So that'll show up in the data it generates. At its core, it can't do maths. Now, the more modern incarnations of these tools have kind of programming and maths tools built into them so they can do maths. But there's kind of problems here that talk more to the challenges they have with doing logical reasoning. Their job is to predict text. And that doesn't mean you can plan ahead and predict the future. That means you're good at predicting text. And it's very easy to show examples where this breaks it. That doesn't mean it doesn't work. That doesn't mean it's not incredibly powerful. It just means there's limitations. So I just want to show you quickly a few kinds of things we can do with these as academics. So firstly, as I said, the strength is in writing. Write a letter to a student or write a reference letter. There's a few things I need to say, but I want it formatted well. This is what it's great at. Change text to be more formal, improve it, write a paragraph or a proposal or a report or something discussing a certain concept. It's amazing at doing these kinds of things. It can be useful for research. Summarizing text, give me some references, although this is a great place where it makes references up. People are trying to get better at this. A lot of the tools are getting better at this, but it's still something to check. It can explain concepts, particularly if you ask it, explain it to me as though I was an 8-year-old or a professor of mathematics or whatever it is. It can write some code. It will usually mostly be right. There might be some bugs, so you might need to help it a bit. It can help you analyze your arguments, look for weaknesses. It can even fit functions to data, and I'll show you an example of this soon. And finally, we can also use it in teaching. It can generate questions to test concepts or answer certain questions to give you memos. It can explain things step by step or describe examples that might appeal to different kind of students or even evaluate answers. Now, again, a lot of these must be used kind of with your eyes open, but there's a lot you can do with this. Let me show you a couple of these examples. One quick caveat, you've got to be careful when you share personal data. If you upload personal data into it, that technically belongs to the company. You might be violating local data protection laws by doing that. You've got to be careful on that front. All right, so just to show you a couple nice examples of things that I find useful. It's very good at talking to your documents. So what did I do here? I went to ChatGPT, the new version 4.0, and I uploaded one of my old papers and I said, what is this paper about? Very briefly explain the basic principles to me. And sure enough, it did that. Got it mostly right. There were a few things that under or overemphasized, but it did a great job of that. I then said, okay, how do the authors formulate this problem mathematically? Sure enough, I pulled that out. So I can ask very specific questions about these documents and get very kind of relevant answers. And finally, I even said, suggest an application for this work. And I was actually really impressed by this, that it came up with a very cool application for this very theoretical technique I'd come up with. And it did a reasonable job of formulating that mathematically and so on. So that's one very useful thing to help us kind of wade through papers and the literature and come out with the nuggets that are useful in papers. Again, I don't think it's a substitute for reading the paper in full, but it's certainly helpful. I find the data analysis very helpful as well. Again, this takes a bit of tweaking, but the kinds of things you can do are like this. So I gave it a spreadsheet with the South African Rand and US dollar exchange rate data, not telling it what it was, and I said, load this data. Now, the later versions of something like ChatGPT, but all the tools do this, they code and you can see the code, so they can actually do these things for you. So it loaded it and gave me a summary of what it was. I then said, plot the data. And sure enough, it drew a plot. Now, the fact that I could say plot the data and not plot the data that I loaded previously is because of those transformers, right? It's looking at all the text that's seen in our conversation to figure out what I'm talking about. When I say data, what am I talking about? So sure enough, it drew a plot of the data, right? Then I could say fit a 9th order polynomial to the data and plot it. And sure enough, it can do that, right? It can fit this function, but now I might not trust it. So I can click on that button that says show work, and it will show me the code that it generated to do that. Now, this is something I could have done myself, but would have taken me more time. And for many people, this isn't in their skill sets. So again, you want to check what it's doing, that it's not lying to you. But like, this is incredibly powerful. And I can then go further. I could say, identify the largest single day jumps in the data, mark these as shaded boxes on the plot. And sure enough, it marked that and it pulled out these jumps. Now, I'll say something like this. I had to give it the instruction a couple times. It didn't quite get what I wanted. It took a bit of collaborative work between me and ChatGPT to get this right, but this is certainly possible. And again, something that maybe in the past I would have needed an analyst to help me with. But then let's turn our attention from the research side quickly to the student side. What about our students? If we're using this, aren't our students using this? And this is like the big question in education, right? That obviously everyone's plagiarizing, the world's going to end, it's all a disaster, undetectable, we're all doomed. Now, I say undetectable, it actually is detectable, but absolutely you should not be using these tools, right? An automated checker, what it does is it says, this text is it most likely generated by a human or a machine. The problem is that the tools are changing all the time. If you don't know what you're doing as a student using this tool, it's very obvious to tell that ChatGPT was used to do it. But if you do know what you're doing, you can upload your own documents. You can say, write this in my style. You can make it basically impossible to check. In fact, OpenAI, the company that makes ChatGPT, turned off their own checker because they said it's not possible to check in general. So this can't be checked. There's no silver bullet to this, which is unfortunate. But all the financial incentives are around these tools getting better and better and more human-like. On the other hand, this isn't a new problem. There are already enough tools online where students could pay for answers. And I think one of the amusing things for me is that some of those systems have gone under now because they can't compete with ChatGPT. So we need more robust solutions to this. And what I think we should do is acknowledge that these kinds of tools aren't going away, but they're getting better all the time. Students absolutely should be using it, and we should be encouraging them to do this, accepting it, and adapting, right? So we want to know, how did they use this? Did they fact check what they did? And most importantly, did they learn what we wanted them to? Like, we don't give assignments because we like giving assignments. We give it because we want our students to learn something. And so this is what we should be looking at, right? On the plus side, this levels the kind of communication playing field, which I think really acts against many of our students in many cases. That, we've got great students, but because they don't know the right language or languages aren't their strong points, they're handicapped. This is a way to get around that. So anyway, back to the problem. How do we think about this? Well, to me, this is about empowering a shift in education. And I think generally this is what we all want to do as educators, right? We want our students to learn to think about content rather than just learning the content we give them specifically. But this is difficult without the appropriate tools, right? I would like my students to be able to learn these kind of questions, of being able to debate ideas, discuss ideas, look at matters from different angles, weigh different sources of information. That's really what I want them to get. But without the right tools, that's really hard. I only have so many hours in my day that it's very hard to do this. So what kind of things can we be doing? Well, on the kind of cheating front, I think, again, we need to go to, are they learning what we want them to learn? So we can look at questions like, what kinds of prompts did a student use? I ask my students in many cases to submit their prompts, and that tells me, did they just give the question or did they engage with it more deeply? I think one of the most valuable things you can do is give a test after a hand-in. Did they learn what you wanted them to learn? Fundamentally, do I care if they wrote all the words themselves or got some other tool to help them? Or if it was a group assignment, maybe they just sat in the back and didn't pay attention. What I really care about is if they learned the key principles. So if you give them a small test, you want to design this around the idea that if they've done or understood the assignment, they should score 100%. And if they haven't, they should score very poorly. And you can do other things, like tell them you're penalizing factual errors. And whether or not you do this, that means they need to give evidence of the kind of processes they followed to fact check. On the other hand, what we want to do is push their critical thinking, right? We want to look at different kinds of ideas. And these are some of the things I've been playing with. You can get it to generate text with errors and ask your students to find it. So they've got to question what you've written, right? Maybe you've got to generate text and they've got to use class material to support or refute it in a kind of in-person exercise. Maybe they need to generate text or generate different sides of debates using the tool or not using these tools to actually have in-classroom debates. And then one of the most interesting ones, I think, is to have students generate text with flaws in the arguments or in the facts and actually exchange this with each other with the goal of trying to find these these issues in each other's text. And so they're incentivized to think deep, look at things from different angles. And I think this is kind of the line of thinking we need to follow to get students engaging more deeply with the content, which is really what we want them to do. So finally, there's a few new tools that we kind of get into our toolbox by being able to use this sort of AI, right? This helps us set lightweight tests. Something that I've taken to doing is giving my students many very small lightweight tests, many of which are kind of auto-marked as they're kind of multiple choice type things. But setting these is difficult, and I can do it much more easily with these kinds of tools. If I do that, I get more continuous assessment to my students without the huge burden of spending a lot of time setting each individual one. You can do some AI-enabled marking. I've had some mixed successes with this. We've had some absolute disasters where it gave a student full marks for leaving a question out, but also it can do quite good things with, if you give it the rubrics and you give very detailed prompts, it can get pretty good at helping with the marking. Again, you want to and really help you to generate their own practice questions or even have conversations with AI. Now, what do I mean by this? This is something I'm really excited about. Now, here's an example. I said to ChatGPT, act as a language partner. You'll start a conversation with me about animals in Portuguese. In every response, provide your opinion and then ask me a question to keep the conversation going. So this is a way that I could work on my Portuguese, right, without being in a formal classroom. And sure enough, we could then have a conversation where it would ask me questions, I would answer, and it would carry on the conversation. And you can do all sorts of interesting things like this. And this is something new. This is something we've never been able to think about or do before with our students at scale, right? We could do it in a one-on-one, but or maybe they could do it in pairs, but if they don't have the deep knowledge yet, this is challenging. You know, the other kinds of things you can do with this way of thinking is I need to practice for a job interview. I'm applying for a junior position as a data scientist at a bank. Act as an interviewer that I'll be for someone I'll be reporting to and conduct the interview. Keep asking me questions. And if I give a weak answer at any point, please indicate this and suggest what would have been a better answer. So again, this is a really interesting new modality where students can use these kinds of tools to train themselves. We're looking at these kinds of ideas within our own university for helping kind of mentor young academics and so on. And I think it's really powerful. So for example, this one here, it says, welcome, thank you for taking the time to interview. Could you tell me a bit about yourself and your background in data science? Now, just to show the point, I said, I don't really know much about data science, but it seems interesting. And then it basically told me that you're useless to me. But then it said a better answer suggestion would have been to demonstrate your familiarity even if you're still learning, blah, blah, blah. And so like this can really help you practice with everything from handling Q&A to giving presentations to, you know, maybe working with people in a clinical setting if you're training for those kind of skills. I think there's so many incredible opportunities in the space that I'm really excited about. So with all of that, I think the important thing with where AI is at the moment is you've got to think about it as you're a scientist or a researcher or an academic, and you've now got a friendly, helpful, but somewhat naive sidekick. It doesn't really understand how the world works, but it can do a lot of things to help you. So you've got to keep checking its homework. And if you do that in the right way, it can be hugely helpful to you. And I think the time it saves you and the skills it brings to you really shaves off the time, certainly compared to the time it takes to check what it's doing. So with that, I'd like to thank you. Here's my thank you as though I was a pirate professor. And I hope this has been interesting and given you some insights that, yeah, are a little bit different. Thanks. Kevins, I hope I wasn't too far over time.
No, that's okay. That's okay, Prof. Thank you very much for the insights. And I will continue to ask people to, there is a lot of clapping, a lot of appreciation of that work. I am seeing some questions in the Q&A. Please put your question in the Q&A. I have seen some in the chat, but please put your questions in the Q&A so that as Susan does the response, then there are some that Prof can answer to, and others we will have them in the discussing. And now I want to introduce to you Susan. Susan is one of us in Qatar for a long time, and Susan holds a PhD in epidemiology as well as degrees in psychology, epidemiology, and biostatistics. She's a tenured professor at the Lalana School of Public Health at the University of Toronto, Canada. Her research interests are diverse and have often focused on mental health and psychoactive substances use and misuse. She has over 30 years of experience as an educator and teaching, supervising students at many stages in their progress. And she has used research, AI in research and teaching in early career. And therefore, we need to hear what Susan has to say about this as we move forward. Susan, please welcome.
Hi, I'm not sure whether you intended me to create a presentation, but I do have a couple of slides. So if I may share, I think that might be, might work. I'll share this screen just to give anchor to the words I'm speaking, might be useful to the participants. Oops, I need to move this back over here because you don't need to do that. And I will, you should be able to see a slide now. Is this correct, Karen?
Thank you very much.
Okay, so where I have been seeing the use of AI exploding in teaching master students, PhD students, postdoctoral fellows, that sort of thing, are in the classic activities of being a researcher and an academic. We're increasingly using natural language tools to discover and find relevant internet sources. Searches are becoming ever more sophisticated with things like Google Scholar and natural language searches. People are even attempting to use these tools to completely generate a systematic review with a great deal of caveat. Quite a few risks are associated with using it to complete a literature review for you. We are using it, of course, in data analysis, in qualitative coding, in quantitative large database analysis, and analyzing images to discover which mammographic image represents something that is actually a breast malignancy and which is a benign disorder. So enormous advances have been made with AI for data and in text analysis. And increasingly, academics are interested in using AI for altering language, to generate language, to take one source of input, such as a very large technical tome, and reduce it in length, in voice, in language, to convert it from technical disciplinary jargon to plain language in order to understand the material, or take your own writing and change the voice to be something that's more appropriate to audience. Even the natural language tools such as Google Translate are increasingly using self-learning algorithms and constantly adapting so they do a better job of altering text that we produce. So this is consistent around the world where people are using AI in education. It's important to recognize that these uses, these things that people are doing, students and learners and scholars are doing with AI, are not new. They've existed forever. You could, as Benjamin mentioned, it has always been possible to cheat. Instead of using ChatGPT 5 or 10 years ago, there was an enormous explosion of organizations that would hire often fairly poorly paid individual persons who would receive by email your essay instruction and your rubric and would guarantee to generate for you a custom written essay. And I have read media reports where those corporations hiring staff to generate essays for university students have been replaced by a fewer number of people driving AI applications and making sure that they'll pass the cheating standards. But we've also had taking a large technical tome and rewording it into a less technical voice. That has always existed in terms of students purchasing a distilled version of a Shakespearean novel or taking Tolstoy's War and Peace and instead purchasing the summary for students so that they get the gist of the story and some of the analysis. So these things have always existed. And we've always tried to find ways of massifying education. Benjamin made reference to attempting to use AI tools to help us generate assessments and to help us with the huge amount of effort involved in grading and assessing student work. So have always been ways we're trying to massify education with good and bad outcomes. These have huge impacts of us. And so part of the impact of interacting with AI tools is to unpack what's happening in the psychoaffective, how people think, how they learn, how they feel, how interacting with these tools affects human motivation to learn and produce. And when you are interacting with some of these tools with learners, such as ever improved literature search tools, it actually can be extremely motivating. The students can quite enjoy working with them. You have a sense of immediate gratification. You get results at your fingertips, where it used to take quite a lot of time physically walking around the library finding paper resources. And you can search ever larger volumes of material and get results quite spontaneously. And working on your own, one can go through the self-learning iterations to do a search in Google Scholar, and you find items that were relevant and not relevant. And you go, oh, I realized that these keywords might help me more efficiently find something that's relevant. So you train yourself, assisted by the computer, and you go through things. So the fact that you can have results and it can be extremely motivating for students, for learners to engage with the material as opposed to not engaging with the material. And there were numerous examples of intentionally going back and forth between what a machine has generated and reflecting on it with expert encouragement and using that to train skills in the learner, so they go back and forth so that they can discern what is useful information, what is valid information, which results apply the learning strategies, the learning lessons of the actual thing, which ones are valid results, and how you tell what are valid results. So it can be extremely empowering. It also can be very demotivating if a learner feels they cannot do it themselves. If they feel that they'll do a search and then the expert will say, well, this was relevant and that wasn't relevant. And the learner says, but I don't know now how you, the expert, discerned that this was relevant and this isn't. I'm not understanding the fundamentals to pick which is relevant. All I'm seeing is an avalanche of information coming at me, and I'm not gaining in my ability to discern and select. Sometimes the pace of work, the skilled students in the classroom driving AI can be working extremely efficiently. That makes the student who needs to learn at a slower pace even more overwhelmed. They may perceive shame if they're using AI tools, having to trust them and not being able to admit or engage in the fact that they're overwhelmed. It may actually create a barrier that distances them from the educators. Longer term, the AI tools can have enormous benefits or enormous risks in terms of the long-term learning in the person who's engaging with these tools in an academic setting. Benjamin made this point very clearly, that it's very important to develop the critical thinking skills to assess and critique the outputs that you get from AI tools. So an article today in Higher Education, the Chronicle of Higher Education, was reinforcing that to use these skills effectively, it is essential to first understand the foundational concepts that are being automated and enhanced using AI. So you should have skills at literature search or data analysis in a slow, step-by-step, visible, algorithmic, and logical way, and then enhance those skills by turbocharging them with an AI tool. So I find myself falling back on an expression that we will not all individually be replaced by AI, but 100 people may be replaced by one skilled, logical, critical expert who is driving AI applications to their desired effect. So there were many examples in Benjamin's work where he was interacting with students to help them to achieve those skills of discernment so that they can take those foundational skills and then soar with them using AI terms. And another potential long-term impact of students who are heavily reliant on AI tools is that they may achieve a success or avoid some of the cognitive learning that we want from them. A colleague at my own university is advocating for students who have difficulty with reading comprehension for very academic work, which is beyond their prior training and experience. They may be first generation to higher education. They may have, they may be studying in a language that isn't the language of the home. And you can use AI tools to translate and summarize and distill and change the language from highly technical, highly advanced grammar, very academic language, which anybody in the world who has academic training would understand, and bringing it down to a more plain language, lower literacy voice. If one constantly translates down to a low literacy voice, they aren't actually also learning academic language. They may be mislearning the jargon and technical terms of their field, and they may not be achieving that very high level of expertise with advanced grammar in any language, English, French, Swahili, or voice. How does one communicate irony? How does one communicate factual information? How does one communicate a procedural voice of a method section? How does one craft rhetorical arguments, authentic and fair-minded rhetorical arguments, or dirty pool, misleading rhetorical arguments? If everything's being translated to a simple common language, are they really learning how to drive language so that they are empowered to not be fooled by somebody and to convince people with appropriate argumentation when they want to? So that's what I wanted to raise, that I really loved Benjamin's presentation. I resonated with a lot of what he was saying in terms of the need to interact with the learner as the learner is interacting with these tools. And I'd be happy to answer other questions or respond if the participants here have questions in the chat. And thank you for giving me a chance to react and respond.
Thank you, Susan. Those are wonderful thoughts through and through. I have a number of questions that are in the Q&A. I also have some that have come in the chats themselves, and I will single out a few so that we can be able to answer some. And some of them are congratulations for the good work done and that. So we will not go back to them. Some others are asking whether we will share the slides at some point or the recording at some point. And yes, we are going to do that, but it has to go to some production first. Then we can be able to share the recording, the video recording in our platforms. Thank you very much for that. I'll only take about two raise hands. Then from there, I will I'll go to the Q&A section, and then we're going to see how many we're going to answer. I'll start with Patterson Kilumba. You raised your hand, sir. Going on, going to, all right. Sikuko.
Good evening, and I want to thank you for this webinar. Actually, I've learned a lot what AI can help us in terms of research and all that. So all I wanted to ask in regards to AI tool being incorporated in research and the other related field is in terms of just leveraging knowledge and making sure that the work produced or whatever the outcome of whatever you're working on, it's not a copy paste of actually what someone else could be using the same tool and doing. What are the strategies or the control measures in terms of using AI?
Thank you. I will take another one.
First, to congratulate you, team, for the good presentation. Just like the first speaker, I wanted to know, like, how can we use AI to escape plagiarism, which is keen in academia?
Thank you. We go to the questions on the chat. As you answer those ones, Benjamin and Susan, then I'll scroll to the chats and see which ones I'll have. Go ahead.
Okay, so you're happy for me to jump in here?
Yes, I am.
Cool. Okay, so I think you know, there's a lot to be said about this, and a lot of I think the correct way to be navigating this is still being debated, and there's different protocols in different academic circles and so on. But maybe to some of the core questions, kind of what I was trying to get at in the talk with the way that these neural networks work is that they're not just generally copy pasting things. Now there are cases where something they generate can be seen in their training data. We don't even have a lot of insights into what the training data is in many cases. And these kind of artifacts are being studied, but in general, when it generates, like generative AI, when it generates something, it's generating something new. And there's this is kind of by virtue of the way that this kind of system works. And I think by analogy, I often think about how our own minds work when we remember something. You know, when you remember that glorious summer afternoon on the beach, it's not like you've got a photograph in your brain somewhere that you're, you know, double clicking on and opening up. Your brain is regenerating that image every time. Every time it's slightly different. And I think that's a useful analogy in this case, that every time, even giving the exact same system, the exact same prompt, it's going to generate something slightly different. So if two people use it, it'll generate different things. Now, again, there are cases where it's close enough to something it's seen before that this causes copyright infringement, but I think in general that's not a thing to worry about. I think so when we talk about kind of plagiarism with these systems, in a way it's not really plagiarism. To me, it looks more like if you'd asked your uncle to answer the question for you. It's still a lack of integrity, but it's somewhat different. So that's why the plagiarism checking thing isn't like a perfect, it's not a perfect map to that. It's not like, you know, if you use a Turnitin or some other plagiarism checker, it's saying like, well, you know, 23% of this exact text appears in something else. Whereas, you know, with checking if an AI generated something rather than a person, it's a bit of a different question, right? And so that makes everything from the checking of it to the enforcing of it quite a lot more challenging, because it really is that question of how do you know that this researcher generated this and it wasn't their best friend at the bar the night before, kind of thing. What this means is that we've got to think about the text that we consume, that we engage with, in a different way. We can't be kind of superficially thinking about kind of exactly the wording of text or the provenance of an image or something. We've got to think a little bit deeper about the meaning that's conveyed, the way that we're engaging with it. Now, exactly how we do this is, I think, a bit of an open question still. I'm sure Susan also has some thoughts on this topic, but you know, I think there isn't a silver bullet to say that, you know, well, you know, you could just go to the great repository of everything AI has ever generated and see if it's in there. And you can't, you know, we've got to be more, and that's why I advocated in my talk about thinking about different methodologies of, say, for example, evaluating students. I think we've got to ask the same questions about how we evaluate research papers and how we evaluate kind of any intellectual artifacts that come out of our profession.
Susan,
maybe you want to...
Yeah, agreed. You know, the academic integrity part is again, take it back to if you think logically about the goals of education, scholarship, and academic integrity in all aspects. If you remove the AI part of it and think about foundational principles, then that guidance is sound. To give an example of an analog solution to doing, one of the questions in the chat was, can I use ChatGPT to perform a systematic review of literature? And the answer is not entirely. You cannot effectively, there articles have come out quite recently that showed that people who attempted to run a systematic review entirely using ChatGPT and such, that there were hallucinations, that there were false summaries of the reports. Before computers, you could go to a book that was written by an expert that was a secondary source. And Subandi has written a chapter, and I cite one of Benjamin's papers. And I cite it. A student and a learner and a scholar was always responsible for going back to the original paper and making sure that I didn't mischaracterize, that I didn't take it, that I actually had read it myself, that I didn't take a sentence completely out of context and change the meaning with malice intended or otherwise. All right, so if you attempt to perform a systematic review using these tools, you are still accountable to repeating the search manually so that you have a defensible algorithm. You are responsible for every single step, every keyword, every link, every Boolean operator. You are still responsible to going to the original sources and assessing them. However, going back and forth with some of these ever smarter tools can help you to learn which keywords are most effective. What you may discover bodies of literature that you didn't know as you crafted your original search and were reliant on your own knowledge and your own filing cabinet drawer and your own mentors. So going back and forth between these tools is a really good strategy, but you are ultimately responsible for everything. Last week, a friend of mine, just a neighborhood friend, she happens to be a banking executive, and she asked Copilot or ChatGPT, can't remember which, to summarize the reviews on a city that she was planning to visit on a vacation with her mother. She doesn't have time to read tons and tons of websites, and it generated a summary in plain language that said, here's the themes of positives and here's the themes of complaints. She's not publishing that. There's no professional harm to her using that summary. It saves her time. The stakes are high, so there's no intellectual property violation. It was an efficiency tool. It was a brilliant thing. I wouldn't use that sort of thing to put into an academic paper for credit. I wouldn't publish something like that. I would explain that had been a guideline, and I would have to repeat the work in a defensible, fully transparent way. Show me the code, as Benjamin said. Show code. I need to be able to critique and defend the work if I'm presenting it for high stakes. So it's always a balance point. The logic of the ethics, the logic of the accountability, the logic of the defensibility, the replicability is always in place. The flashbang of new AI does not remove any of those responsibilities.
Maybe kind of add to that a little
Go ahead,
bit.
Benjamin.
And say, yeah, I completely agree with that. I would say that if you know what you're doing, generally using these tools is going to give you a far better output. But, you know, and we certainly use it in our research. There was a case kind of at the beginning of the year, we had a whole team of about 8 or 10 of us writing a paper, and we, you know, there was certain bits of phrasing we couldn't get right, and we'd go to ChatGPT and get it to help us do that. And it was amazing. Like it really came up with some great stuff. I wouldn't just give it a task of like, write this paper for me, because I know I can't, you know, maybe I get lucky and it's all great, but like, you know, I don't want to run the risk of that. So again, I think it's worth thinking about AI as like, you've got a super enthusiastic but naive assistant who like can go and do lots of stuff for you, but like, you want to be 100% sure that like if you're putting your name on something that you've double checked it. There was a kind of story quite early on in the ChatGPT era where I think there were lawyers in New York that got a case thrown out of court because they submitted their documents and they'd used ChatGPT and all the references were made up. And they just hadn't looked at this. And so, sure, like they should definitely be using ChatGPT to make sure that their arguments are as strong as they can be, and to say, you know, can you point out the flaws in these arguments? I mean, I've used it in a variety of different ways. And, you know, again, this goes from helping me with research, but again, I'm not signing off on something in the same way I wouldn't give something to an undergrad student, run with this, write the paper, and I hope it gets accepted. My name is on it. I would never do that. I wouldn't do that here as well. But you know, by the same token, I've had times when, actually there was an example I had recently where I was sent some legal documentation I had to read, and I'm not a legal expert at all, so this would take me many hours of my life. And I went through it and I thought I knew what was going on, and then I asked ChatGPT, are there any things I should pay attention to here, or anything I should flag? And sure enough, there were a couple things that it pointed out, and I sent this off, and the person said, oh, well caught, we didn't notice that. And so it can be very useful, but it can also make up nonsense. And so definitely, it's all about the balance. Think of it as this new super tool, but one that requires some attention.
Yes, and if you did have to learn, if you were going into a situation in your professional life or your personal life where you were going to have to read legal documents again and again, and going back and forth and saying, well, this, I didn't understand the legalese, and here's an interpretation, and then checking that the interpretation was correct. You can go back to the original again, and you become ever more effective and efficacious at reading the original work. So you're training yourself to do higher level language.
Thank you. Thank you very much. I'll take two questions from the chats. I have seen quite a number of them have actually been answered on literature review. The ones on data and again, literature review, I will ask us that we register for the one that is coming on 17th. That one will be specifically for review, literature review, data analysis, and that. So please get to register for that. You get more information on that. Now for Dixon is wondering whether GPT can generate research ideas if given enough data to look at. And someone else is wondering, I am doing a master's education planning management degree, and I would like to know the right tools that can help me excel in my grade. I think that's general AI use. And then currently students use AI tools without practical policies. This is very, very important from Abdinashir. Yeah, how could universities set policies and ground rules of use of this, of AI in the universities? Thank you very much. And can we respond to those? I am looking at my clock and my clock is ticking. So I'll take those, and I promise Majani to read his question on the chat, and then we will end that session. Please,
let me jump in briefly on university policy, because my University of Toronto, has produced a website now which is extremely rich in terms of academic policies for AI, and it will be updated. Many other research-intensive universities are, so a link to that is just one exemplar, not the world's definitive piece, but a nice example, can be distributed with slides.
Thank you, Benjamin.
Thanks. Yeah, I think, on the question of policies, because this is a relevant thing for, I mean, definitely, I think that's the right kind of resource to look at. I think with anybody thinking about these in their own institutions or countries or companies or wherever they are, the one point I would add to this is that this is an incredibly dynamic landscape. So, I think AI is now the fastest growing field in human history. There's well over 300 papers published per day at this point. There's trillions of dollars being invested into it. It's absolutely insane. And my worry when I engage with people in a lot of different industries and different fields, everyone's got this attitude of ChatGPT happened, and now we've got to figure out how to deal with the new normal. And you're like, no. The changes you've seen already are slower than any other change you're going to see in this field in the future, right? You can't just rely on, if your policy document, for example, is just talking about ChatGPT, well, ChatGPT is going to look very different 6 months from now. It's probably 6 months from now, it might not be the best tool. There's going to be something else out there that you should be using instead. In fact, in many domains, that's already the case. And so I think it's important that any policy documents focus more on the fundamentals rather than like the particular flavor of a particular tool or the current version of that. So that's just one thing I want to flag on that front. And there was a question of what are the right tools? I don't know. I think I saw a statistic recently that there's something like 70,000 AI companies in the world at this point, most of which have been formed in the last 2 years. Again, this is an exponentially exploding area. For the general text generation type things, there's things like, ChatGPT. I think GPT-4o, which I think is now free, is probably the leader on most fronts, but there's other tools like Claude from Anthropic, there's Gemini from Google. There's a whole lot of these things. Each one's have their strengths and weaknesses. Really, what I advise is you've got to play with different tools and see what works for you. Like, there's a lot of then smaller tools that are very purpose-built for niche applications, and in many cases, those are the right things to use. But that's going to depend on you, your context, what you're working with, and that sort of thing. Then there was a question about, can it generate research ideas? And I think this is a very interesting one. I know some people would find this controversial. I think absolutely. I mean, as I showed you, there was that I gave it that paper of mine. I asked for it for an application of my work, and it gave one that I thought was really interesting, and it fleshed it out in like very valid ways. And I think a lot of this comes down to the fact that, you know, we don't like we place a lot of value on human creativity, which I think is maybe misplaced in some ways. Usually we're piecing together different ideas in interesting ways. And I think this is something that it's quite good at. It's read a lot of text and it can piece together different ideas. Again, a lot of the things on the surface might seem great and they might not actually be. Some things might be. And I think, again, the correct way to use these tools is as a kind of back and forth kind of thing. Often I'll have an idea and I'll go to ChatGPT and I'll say, are there any obvious like problems with this idea? And I'll iterate a bit. And then I'll go to ask some of my human colleagues, and then they'll point out completely different things. And, you know, it's through this collection, like working collectively, that we get better results at the end of the day. So I think I would be very cautious of anyone dismissing this, saying obviously not, you can never come up with new ideas. Like I literally showed you in my talk that it could, but again, that doesn't mean every idea it comes up with is going to be great. Like, you know, if you wanted to invent a teleporter, I don't think it's going to come up with the answer for you. It's going to come up with things that are kind of maybe not too big a logical leaps from combining ideas that
putting AI specifically in scientific writing into our curriculum, I think they are. Is it feasible, or we are too ambitious in the manner that we are going to lose the target and producing dependent students with zero competency, specifically in the realm of critical thinking and reasoning?
Let me jump in on that one, because there is a pressure in post-secondary education for efficiency of the students' input in terms of effort and the quality of their learning for the time and the money put in. And in order to achieve better critical thinking, critical writing, good grammar skills and such, it takes practice. It has always been, and that practice can be facilitated by going back and forth with AI tools. Absolutely. Write something and then observe what it did that is different, and how can I imitate that? And then how can I review what AI writes and tell me if it's better work? The best ways of doing that and avoiding plagiarism and everything else is to have human interaction with the writer going back and forth, so that the students learn as their skill. It is very difficult to massify effective pedagogy to enhance critical thinking and reflection and feedback. So you can do a lot of stuff with mass numbers of students, but to give them meaningful information that they actually see themselves and improve themselves takes a lot of resources. But possibly one reason that we have so many essays in undergraduate training, for example, is people will say, well, students need to learn how to write. And so you give them a writing assignment, and then you get to their second year undergrad and they still can't write. So somebody gives them another writing assignment, and then a third writing assignment, and then a thesis, and they can't write a thesis. And so we give them writing training to write their thesis, and they still can't write. Because it's not about repeating ineffectiveness, it's about learning how. And so in only one stage of their education, if they have an intimate, meaningful coaching on what writing is, how to do it with back and forth practice, they could do it in one semester and be done and not have to repeat and repeat and repeat. Repeating and repeating failure, repeating and repeating avoidance is a terrible situation for a learner to be in. You want to have skill development and mastery as efficiently as possible. And that probably means at some point having intimate interaction. So advice on how to avoid plagiarism now that these tools are out there often loops back to having a conversation, a dialogue after the students have produced some work, to talk to them about how did you use AI tools, or how did you write? How did you improve? What feedback did you give? Asking them to discuss and describe to each other or to you the kind of iterative loops that Benjamin talks about, that as he uses these tools, as he uses them critically, as he uses them in iterative loops to improve the product. So there really isn't any substitute to intimate classical pedagogy and feedback. Development of critical thinking skills and critical writing skills is foundational. It can be enhanced by AI tools, but it doesn't wipe out the need for intimate pedagogy.
Thank you, Susan. 1 minute, Benjamin, to jump in, and then I'll close. 1 minute only.
Cool. I totally agree with that. I think, if you're not using AI, like one of the most powerful is when, I don't need a student to be the best writer in the world. I need them to be good enough. But there's no way I would just leave a student and say like, okay, now that ChatGPT exists, go out and do all the things, right? There's a reason I meet my students multiple times a week. It's because like when they're doing research, I need to be guiding the process. And so, they've got to use all these resources together. And I think, again, there's no equivalent for the human contact. However, there's many cases where that's not possible, in which case this is a really nice alternative in some way to help you. But I don't think it exactly matches the full experience.
And there will
Thank you.
always be the human thing, like who is interested in developing their skills. Student motivation is foundational, and it is not always entirely under the control of the instructor.
Thank you, Susan. Thank you, Benjamin, for your time and the interactions. There are questions that we've not responded to. Some have been responded to. We're going to analyze these questions, and they will be forming part of the discussions on 17th with our facilitators that will be there. So please bear with us because of time. Thank you very much for your attendance. I want to make a small announcement that we at Carter, we have introduced what is called the community of practice. And that community of practice, I'm going to give Bernard 1 minute. Bernard, are you here? 1 minute to just make that simple explanation. Then I will welcome Flora to do the closing remark. Flora is our end of research and related capacity strengthening unit and a manager in Carter. He's profoundly talented and able to give us a good closing remark in view of this and point us forward on what we're going to do. All right, I will give a small one. If you go to our Carter website and you want to be part of the community of practice, there is a link that will lead you to that. And that link is going to help you register. And then we will admit you to that community of practice, not necessarily on AI, but is on research and research training and the things that go around that area in publication and that. Please go to our Carter website and you get this. Dr. Flora Karimi to do the closing remarks as we come to an end of this webinar. Looking forward to seeing you on 17th. Thank you very much.
And thank you, Cavens, for just moderating this session. I want to also take this opportunity to thank Sue and Benjamin for the great work that they have done. I think for me, one aspect that came out so strongly is the fact that we need to demystify the whole aspect of AI and also to break down some of the jargons that we are used to mentioning. People will mention about machine learning, and some people would panic because the jargon seems to be so complicated, or even AI, or even the chat GPT. But you have been able to break this down for us in a way that I believe even the different participants who are here, who are more than 230 at a particular moment, really got a lot from what you led us through. So thank you very much. I think for me, other aspects that also come in handy is the fact that I think it's Benjamin who mentioned the fact that we need to take the AI as a whole, as a friend, but yet realize that it is, there are tools that are naive. And so as a result of that, then we need to engage in that space, knowing that we need to personalize the information that we are getting and engage in it in a way that it gives us exactly the direction that we want to go, which cannot happen unless we engage with the information that we get. Secondly, was the whole aspect of acceptance. We just need to accept the fact that we are in this age. We need to accept the fact that we need to engage in the AI space, and also accept the fact that we need to adapt. I think those are words that I cuts as Benjamin has developed assessment tools that will be able to benefit us. How do we ensure that learning is still taking place, critical thinking is still taking place, and that we are able to develop different skills in individuals? So it calls for us as researchers, as academicians, to also change our approaches. We might be so fixed in particular approaches, but maybe it's time for us to say, I have to accept the fact that AI will continue moving forward, and it will continue changing from one thing to the other. And so how do I ensure that I have kept abreast with what is happening and that I'm flexible enough to adapt the changes that are coming? How do I make sure that even in the area of plagiarism and aspects that may not look ethical, I have been able to guard against getting out of what is expected? So thank you for those challenges that we have received even through this particular webinar, and we look forward to going on with the discussion about AI as we continue learning how to demystify it, or even to enhance the use of the AI tools in what we are doing. So we look forward to seeing all of us and even more during our next webinar that we will be having on 17th. And for now, have a good evening, have a good morning or afternoon, and thank you.